MIT.nano is a new 215,000 square foot nano fabrication, nano metrology, nano engineering and science building on campus. It's a shared resource for all of campus. It's intended to help amplify the work that people are doing at the nanoscale and to help us identify new areas that really require operating at the nanoscale. If you look at the junior faculty in the School of Engineering and School of Science, over 50% of them are doing work at the nanoscale. That doesn't mean they're all doing semiconductor electronics. That means they may be doing surface modifications. They may be changing the hydrophobic properties of a material by making surface modifications at the nanoscale, or they may be growing materials at the nanoscale, or making sensors at the nanoscale, making nanoscale particles. Nano is nothing more than a dimension, 10 to the negative 9 meters, so just really, really small. To do small work, you don't want your building moving. You don't want particles that are in the air that are bigger than the thing you're trying to create interacting with the sample that you're trying to design. So the structure of MIT.nano, it's low vibration, low noise, low dirt, temperature controlled. The building itself sits on 90 concrete trucks worth of cement to make sure the building never moves. It sits on this large inertial mass so that when I am trying to image something at the atomic scale, that the building is not moving. The building is structured in a way that the bottom floor, sitting on top of the inertial slab, in the bottom we have imaging suites that allow us to do characterization and imaging at the atomic scale using new cryo-electron microscopes that give us atomic resolution, that may be atomic force microscopes that give us characterization of surface properties. But each of these imaging bays in Nano allow us to visualize what's happening at the nanoscale. The next two levels, in each level is 2 floors, are our fabrication spaces, clean rooms that allow us to manipulate and grow and modify material at the nanoscale. And that can be semiconductor processes, wafer-based. It could be roll-to-roll printing processes. It could be fiber extrusion processes. The fundamental theme, if I were to oversimplify it, of MIT.nano is that we're innovating in materials, we're innovating in processes, and we're innovating in devices. And unlike a conventional fab that you would find in industry, we want people to do experiments. If it takes us a week to clean up a piece of equipment after it's been contaminated with an experiment of new material, that's okay. We want to push the boundaries of engineering and science and understanding and allow the community to work with us, to work with the visiting scientists that are part of MIT.nano because of our industry collaborations, to work with the MIT scientists that are the lead technologists in understanding how each piece of equipment works, to provide that opportunity for the entire MIT community to practice their field at the nanoscale is what MIT.nano is about and what those 2 floors of fabrication allow us to do. The final floor of MIT.nano is the top floor. And on that top floor we have the new chemistry teaching labs, so a collaboration with the Department of Chemistry, but also prototyping and assembly capabilities that allow us to ask the question of how do we now take things that we've imaged at the nanoscale, fabricated at the nanoscale, and interface them to the macro scale, the micron and up, to make them so that we can touch them and hold them and have them in the environment and not require the clean room that is on the lower floors. MIT.nano is a resource for the community. And that community is not just MIT faculty and MIT students. It's a resource for the companies that we collaborate with. It's a resource for big companies and for small companies.